So can you hear me? Okay, thank you, Eunice, and thank you, Ismail. Yeah, so uh, yeah, so thank you for joining early. Yeah, so apologies, I was not able to attend the lecture in the like in the past 2 weeks, I think. But I think 1 week it was because of the holiday. And last week I did not manage to get alternative to compensate for the lost time. So let us start. So what I will do today is just, try to continue a bit from where we ended last time. Because if you remember, I introduced the risk sharing reinsurance. Uh, sorry, risk sharing through reinsurance. And we covered a number of stuffs, of course. What are the typical types of reinsurance policies, which an insurance company, of course, can take. But what we care the most in this course is how can we actually try to estimate the claims which an insurance company has to pay, right? Or insurance company, of course, has to pay, right? We don't care much about how do we estimate the premiums then, right? Because that is the other issue then. Because if you have different, different insurance policies, now the next question is how much should you pay for this policy and how much should you pay for the other policy as well, right? So this is actually what we covered last, I don't remember which, maybe the past 2 weeks. I hope you remember this stuff. I hope you have gone through these stuffs. And I think we ended at some point like here, right? So I said, of course, this is a very simple integration, I think, because what you have here is that you have X power K. We just interested in like in developing a simple formula which can help us to do the integral, because otherwise, if you don't do that, then imagine, because if you're talking about excess of loss reinsurance, you have the two parts. So you have to take the integral from 0 to m, and then you have xk, right? And then you multiply with the PDF. But we are saying, what if, your PDF is somehow complicated? We are saying, let's say, assume maybe you have a log normal distribution, right? Not very complicated, but probably time consuming. So we are saying, if your f of x in this case here is log normal distribution, probably you can have something which is simple. And this is not limited only to a log normal distribution. We're using log normal distribution just like an example, right? But this is special case distributions. You can have log normal distribution, you can have a normal distribution, right? We are saying if we have a log normal distribution, then taking the integral of this part here is simply equal to taking this part here. And then, of course, you multiply with the difference between the CDF. So you have the CDF, you evaluate this CDF in the upper bound, which is U, and then we subtract with this CDF in the lower bound, which is LK in this case here, right? Where LK and UK is actually defined by this one here. So what I say is that I say, because I shared the source where I've taken these materials, of course you can go through it and then you can see how to prove this one here. It's not that hard. What I believe, is it's just, easy, because you just need to simplify the log normal distribution here, right? So just put the log normal distribution, and then you take the so it's E minus 1 power log of X minus mu divided by sigma, and then I think you let that part equal to something, and then of course you simplify it, right? So that is why I said, okay, this is just an exercise. You can try, to do this, because it's I think it's just simple manipulation which is involved in this part here. So then I said, okay, so when evaluating that integral, probably at some point, because we want to simplify our life, and we are saying, of course, we know what is phi, right? Phi is simply the CDF, and of course, I will show you soon. I think I showed this one here probably at some point. I will try to switch to my iPad so that I can demonstrate this one here in details. For those who have not yet covered this part. So let me go here. So give me one So just a few seconds. So I'm going to switch this. Okay, so what I was saying is that so if you remember from so let's say this is a simple calculus, right? Because if you have, let's say, we know a normal distribution, this is our normal distribution. Normal distribution look like this one here, right? And then we are saying if we have a normal distribution, and of course this one is this is half of the distribution, right? This, I mean, at the middle part is half of the distribution. So we are saying now, suppose maybe like this is your infinite, maybe this is minus infinite, and stuff like this one here, right? And this one here, of course, is 0. So what we are saying here, because we know what is phi of x, right? Because when I write phi of x is equal to probability of x, I mean, less or equal to x, right? That is why you'll see that when I say phi of positive infinity, this one should be equal to 1. Why? Because we know the total area under the curve, right? The total area under the curve, in this case here, this is the normal distribution. The total area under the curve, in this case here, will simply be equal to, or will be equal to 1, right? So phi of a positive infinity should be equal to 1, right? Because that is the total area of the normal distribution. And then, of course, we said, because this is a standardized normal distribution, right? So this part here, the area under the curve in this part here, I mean, is 1/2, and this area here again is 1/2, right? That is why we are saying, because of this symmetrical property of a standard normal distribution, we know that if you take the phi of 0, this one here should be equal to 1/2, right? Just half, right? Because it's just like you are saying, what is the probability of x being less than 0. So we are talking now about this part here, right? So this part here should be equal to actually 1/2. And then we are saying the other issue here is phi of minus infinity, right? So if you take, I mean, like you try to evaluate, find the area of this curve, right? When, I mean, your x is very small, because this is minus infinite. When it's very small, of course, you are talking about this part here, right? I mean, like in the tail. So if you estimate, I mean, the area, right? If you take minus infinity, for this one should be equal to 0 or very close to 0, right? And stuff like that. So we need these properties when we try to evaluate the integrals, right? They actually make your life easy, right? So I will show you in the example which we have. So I believe some of you have already done something maybe regarding this example here, because this is where I left last week. And we have this simple example that an insurer is considering taking out one of the following insurance treaties. So you have the treaty 1. So we have two options here. So the insurance company can either take treaty 1 or the insurance can take treaty 2, right? So we said treaty number 1 in this case here is simply proportional insurance, right? Because you are sharing this one in terms of proportions. And this one here is actually the excess of loss. So you have either of the two. Do you want the proportional insurance, or do you want the excess of loss insurance, right? And what we are saying in this part here is that, okay, now suppose you have these two options here, T1 and T2. So I'm going to denote this one here by T1, and I'm going to denote this one here by T2. So we have either either T1, which is proportion reinsurance, then we have this one here, which is excess of loss. So we have to make decisions between the two, right? And what I'm saying here is that find the mean of the net claim amount paid by the insurer. So how much was paid by the how much will be paid by the by insurer under these two scenarios, right? Under the first scenario and the second scenario. So in the first one, we have to find the mean without either treaty. And the reason why we are doing this, probably we want to compare what happens if we take reinsurance, right? And we know that we can take reinsurance of either proportion or of excess of loss, right? So we are trying now to see, suppose we want to do some analysis in this part here. Let us try to estimate how much are we going to pay on average if we don't have any treaty, or maybe if we have treaty number 2 or treaty number 3, right? So we are saying now, right? We are saying assume that the distribution of individual losses is log normal with parameter mu this one here, and then of course you have the variance of this one here. And this one actually is very important because that is why we started with with trying to understand the loss distribution models, right? Because you have to understand you cannot do all these things if you don't know what distribution does your claims actually follows, right? So we are saying in this case here, assume individual losses they actually follow a log normal distribution, right? So and that is why maybe yeah, I will explain this one later, but maybe let us start with this one here. So I will start with the first thing here. So the first problem is we have to estimate the the mean without either treaty, right? So which formula should we use in this case here if we want to estimate the mean of the of the claim amount without any treaty? So which formula should we use? Anyone? I hope the question is clear. So I mean, like, ignore the treaties and stuff like that, right? You just have to find the mean. So how are you going to find the mean of the claims here? Provided that you know these claims follow a particular distribution, right? We know these claims follows a log normal distribution, which the mean of mu and the variance of 0.64. So which formula should we use here? Anyone? Okay, but I hope you can hear me. So what do we have to do in this case here? Because there is no any treaty, right? So without any treaty, we know that our data, right? Because we know our axis in this case here, we know that our axis follows a log normal distribution, right? So we have a log normal distribution with parameter mu and sigma square. So if you don't have any treaty, you don't have any other, you don't have any arrangement, then of course the mean should be estimated by the mean from the log normal distribution, right? So what is the mean of log normal distribution? The mean of log normal distribution is, I think, mu and then plus 1 and then sigma square, right? This is the case where we don't have any, right? You don't have any arrangement. If you don't have any arrangement, of course, simply use the mean from the distribution which you have. So if you could have, let's say, be using a log normal distribution, then of course, without any treaty, and then you're asked to find, let's say, the mean, of course, you simply take the mean of the log normal distribution. So in this case here, of course, the mean will be equal to this one here, but we are given all these values, right? So we are given what is the mu. So the mu is the mu is 8.5. And then, of course, we are given the variance. So the variance is 0.64. So you can see, I think everything now is okay because you simply need to substitute everything in this formula here. And if you do that, I think I wrote it somewhere, but you can try, and then see what you are going to get. Where this. Oh, so I recorded the answer somewhere. Let me check that, and then because we are not going to spend a lot of time. So give me 1 second. Sorry. Find this. Okay, so I think you have tried that. So if you do that, I think you'll get around 6, 7, and then I think 6, 8. So when you get time, try to solve that, and then of course be able to get this value. So this one here is actually the amount which will be paid without, right? So this is without any treaty, right? So if you don't take any treaty, of course, you have to pay this amount. Maybe it's in pound, I don't care, but this is actually what you're supposed to get to pay, right? And then the second part of the question is this part here. So now we have to find the mean of the net claim amount paid by the insurance with treat one only, right? So suppose now you say, let us maybe try to take this policy here, right? So how much are we going to pay, right, in terms of claims? So because this one is proportional insurance, I hope you remember from these treaties which we have here. Treaty one is 25 quota share treaty, right? So if you remember 25 quota share treaty, what actually it means that in these two parts which you're going to have, because you're going to have an insurer and then you're going to have the reinsurer, right? So in this part here, insurer is going to pay, okay, reinsurer. So this is the percentage for the reinsurer, right? According to this treaty. So you have, 25% reinsurer, and then of course the remaining one, which is 75%, will be paid by the insurance company, right? So we are saying if you have this arrangement here, then how much, of course, you will have to pay. But we know, of course, out of the total claim, let's say this is X, right? The amount which insurance company is going to pay under this treaty, which I'm going to denote it by, let's say, XT1, denoting that this is X from T1, nothing special here. You can use any letter, Y, Z, it does not matter. What I'm saying that the amount which will be paid under XT1 will simply be equal to 0.75, and then of course multiply by the original X, because you take, the original X, and then you multiply with 0.75. That is the amount which insurance company has to pay, because they are sharing this one in terms of proportions, meaning that the remaining one will be covered by the reinsurer. So this is how, this treaty number one look like, right? So I will move now with this part here. So I hope that is clear. No, let me know. So now let us try to estimate this one under T1, right? So T1 is actually treaty number one. So now what do we have to do here? We know that, okay, the amount which we have to pay under this treaty is 0.75, and then multiply by the original X, right? So we are saying, okay, this is very easy because we need the mean, then we can take the expectation, right? So take the expectation of T1, right? Of course, take both sides then, and then expectation of X, right? So this one is very easy. Why? Because we know this expectation is already evaluated here, because this one is the expectation of the original distribution, right? So we know that the expected value of X, right, is simply 6768. So this is much, much easier because it will be 0.75 and then multiply by what we have here, which is 67 and then 68. So if you solve this one here, I think you'll get 50 and then 76. So this is actually the amount which the insurance company will end up paying, right, if it actually opts for treaty number one, right? So remember, this one here is without any treaty. So if you don't take any treaty, of course, you'll have to pay this amount here, right? So you can see the difference, right? And this makes sense because if you are going to take reinsurance, then you expect the amount which you'll have to pay at the end of the day should be at least low, right? Otherwise, it does not make any sense. Why should you take the insurance if the amount which you are going to pay on average will be higher, right? So this is expected, right? And if you do computation, let's say in exam, and then you get, let's say, the answer which is larger, maybe it's a good indication that you have done something wrong, right? Yeah. So if you have any question, let me know. Okay. So otherwise, I will actually move to the second part, right? So the third part, sorry. So the third part, we have to estimate how much, right? How much are we going to end up if we take it treaty number 2, treaty number 3? So this treaty here now. We're asking about this treaty, right? So, it's easy to estimate this one here, right? But now, because this is excess of loss. I say it here, right? Treaty number 2 is excess of loss with unlimited individual excess of loss cover with an excess point of USD 25,000. So we are saying, if the claims occurs, and these claims here, I mean, they're actually above 25,000, then of course this reinsurance is going to cover. So there is no upper limit, right? That is what that is actually what we mean when we say unlimited individual excess, right? So there is no upper limit in this case here, right? So as long as the claims exceed 25,000, it's not your problem, it's someone else's problem, right? So this is what we are actually doing in this part. So now let us try to estimate how much insurance company is likely to pay under this switch. So now let us see under T1, which is going to happen, right? So under T1, we know because this one is excess of loss, I'm going to note this one here by X. No. This is T2, right? Sorry, this is under T2. So under T2. So we are saying under XT2, right? And this is just a mean notation. You can use Y. It does not matter, right? So we are saying what is going to happen is that we know the general, right? So we are going to pay X. We're going to pay X, right? If X is less or equal to M, right? And then we're going to pay M if X is greater than M. This is what we said, right? I mean, 2 weeks ago. Then we said, but what is M in this part here? We are given that M in this case here is 25,000, right? Oh, we say this is very easy now because we know we can estimate the mean from here. This is a step function. And we know if you want to estimate the mean, you simply take X under T2, and this one here should be equal to the integral from 0 up to M, and then you have X, and then f of X, and then dx, and then plus integral from M up to infinity, and then of course you have M, f of X, and then of course you have d of X, right? So we are saying this somehow is right. But then I'll show you why that thing, I mean, is somehow important, because now what do we have to do with that? We have to say the mean under xt2 in this case here is equal to the integral from 0 to M, and then of course you have X. What is f of X in this case here is the log normal distribution. And we know what is the log normal distribution, right? So the log normal distribution is 1 over X 2 pi, and then sigma, and then log, and then E, and then minus 1 over 2, and then log of X minus mu divided by sigma, and then square, right? So we have to integrate this one here, dx, and then we have to plus again the other integral in this part here, which is M to infinity. Of course, we have M, which is constant, and then we have to put the log normal distribution again, right? So you can see this is actually what we have to do, right? So we have to do this. So we have to evaluate this, right? So this is how we have to evaluate this one here, right? Yeah, and we are saying, yeah, we can evaluate this one here, right? But I don't know. We can evaluate this one here, but probably maybe it's actually time consuming, right? So it's time consuming. That is why we are saying, probably let us try maybe to do what? Maybe let us try to use this simplification, right? So this actually help us to evaluate that kind of integrals. Why? But remember, this one should be log normal, right? If we not log normal, we cannot use this one here. This is actually a log normal distribution. It is actually specifically for a log normal distribution. Of course, there are other forms like normal distribution, right? But let us focus on log normal distribution because we are assuming all claims for log normal distribution. That is why I don't want to show you for a normal distribution anyway. So now let us use this one here, right? But remember what is K? K is actually the order in this part here. So if you're you are trying to find the integral of X and then maybe f of X, remember X here is power 1. So power 1 means that your K in that case is equal to 1, right? So K is just, I mean, the like the power of the X value you are trying to evaluate in this part here. So that is what I will be using now to evaluate this integral here, right? I hope that makes sense. Kama kuna swali, feel free to ask me. So does that make sense? Yes? Does that make sense? Or you are still sleeping? Okay, thank you, Ali. And thank you, Sharon and Ismail as well. Okay, thank you, Oscar. Yeah, so if that makes sense, then what we have to do here is that we have to now say, okay, let us try to let us start iPhone. Okay, so what I was saying from here, right? I was just explaining from this part here. We said, what do we have to do in this part here? Because we know this. This is actually what we have to do. Let me show you here. So generally, this is actually what we have to do. This one here. We have to evaluate this one, this integral here. But f of x is a log-normal distribution, right? So you have to substitute the log-normal distribution here, right? Log-normal distribution, log-normal distribution. Then, of course, do the integral. So if you can do that integral, yes, is okay. I mean, it does not matter, right? But we are saying we can try to simplify our life because nowadays it does not matter much, right? Nowadays, all this stuff we are doing does not matter much because nowadays we can write a program and a program can solve everything for us, right? But I mean, in years when people were developing this stuff, they did not have these powerful computers which we have nowadays, which can solve a number of problems, right? Yeah, any kind of problem, right? But before it was very challenging, so they had to come up with at least, I mean, simple ways in which they can use to evaluate all these kind of integrals which we have. And one of them in this case here that we are saying, if you want to find this integral here, of course you can start from scratch, but we are saying you can use, I mean, a simple formula, which is here. And this formula here, I mean, is just developed from simplifying the log-normal distribution, right? So you'll see this in the notes. I mean, it's not easy. I just don't want to spend time proving this. But I mean, it's very simple. You'll see that. And then we are saying, so if you have a log-normal distribution, of course, instead of evaluating the integral, which I showed you before, simply use this one here. Use this output here, where we have defined L of k is equal to this part here, and then U of k is equal to this part here, right? So that is actually what I'm trying to do now in this case here. But the idea is simply evaluate this integral here. Can you evaluate if f of x is a log-normal? If you can, just carry on, right? But if you are given this kind of question in exam, maybe it's not a reasonable way to do, right? So maybe use the simplification to make your life much easier. So does that make sense, Ivan? Okay. So let now me move on. So what I'm saying now is that, okay, I will start by evaluating this first integral here. So let me maybe use this, yeah, so let me use maybe this, I don't have other good color here. Anyway, so let me start by evaluating this integral here. So I will start with this green integral here, this green integral. And then after that, I'll move to this blue integral here, right? Blue integral here. But both of them will use the same formula, right? Because remember, we have two integrals here, right? So let us start with the green one. So if you look with the green one will have to find the integral from 0 to m, and then x, and then f of x, and then we have d of x, right? But I know from this integral, right? I know that my m is already given, is 25,000, right? And also I know f of x, this is one is log-normal, right? Log-normal. And then I know the order k. So my k in this part here is equal to 1. Why? Because this one here can be written like 1, right? So you can have 1 here. 1 here at the top. Of course, this is actually the order of your k, right? So now recall from the formula which we have, right? So we said the first thing which you have to evaluate the u of k. You have to evaluate the u of k. So what is u of k? And what is L of k, right? But I know the order of my integral is 1. So what is U1 and then what is L1, right? But we know the formula, right? Because the formula, you simply need to take log of k for u, and then you subtract with, yeah, I don't remember. So you just have to take the log of L minus mu divided by sigma, and then minus k sigma, and then the same for u. So log of u minus mu over sigma minus k sigma, right? So this is what I'll be doing here. So I'm going to take log of k, and then k mu divided by sigma, and then minus k sigma, right? So that is my u. Sorry. So this is supposed to be UK, right? So log of UK, and then let's leave this one here. But we can see this one will be much, much easier now, right? Because we know our U of K in this case here. This is U of 1, maybe for simplification, right? So this is U of 1, meaning that even this one here will go, right? I don't know if you'll remember this one here. Maybe let me, sorry. Let me, before substituting the 1, we know how to estimate the upper bound, right? So the upper limit. So the upper limit is given by the log of UK, subtract with K mu, and then divide by sigma, and then minus K log of U minus minus mu, and then divide by sigma, and then minus sigma, right? Because this one here. And then we do the same thing for here, right? For we do the same thing for LK, right? Because LK now, what is about LK? LK will again be equal to log of L minus mu divided by sigma, and then minus sigma, like that, right? So now what you have to do now is that you just need to substitute now, because we know the U, right? So the U in this case here, U is equal to, what is the upper limit? Is 25,000, right? Because remember we are integrating from 0 up to M. So M is equal to 25,000, right? So I'm saying in this case here, my U is equal to 25,000. So we simply need to put everything there, right? So you have to find what is the value of log of 25,000 minus mu. So mu is 0.85, I think, divided by sigma. Sigma is 0.8, and then minus sigma gain, which is 0.8, and then you have to find the value. And I think if you do that, you'll be able to get, I think, around 1.2332, like that, right? So this simply, I mean, the upper limit. And then, of course, you have to do the same thing for the lower. But for the lower now, remember, it's very tricky, because remember what is our low limit here? So our low limit is this one here, is 0, right? Is 0. So what we have to do now, we have to say, take the log of 0 minus mu. I don't care about the mu now here, because this is 0. But what is the log of 0? What is the log of 0? What is the value of this one here? What is the value of this? Yes, what is the value of that? Anyone? What is the value of that? Log of 0? Log of 0? Undefined. Okay, undefined. Thank you, Faraja. Thank you, Ismail. Thank you, Anna. So undefined. Yeah, negative infinite, right? Yeah. Thank you, Ali and Terence, I think. Yeah, so it's minus infinite, right? So what we are saying in this part here is like, I mean, because we cannot evaluate this integral here, right? So what we are saying is, this log here, it's just from the, I don't know, I have to switch this one here, but I will show you, right? I will show you what I actually mean. But ideally, what we are saying is like we are saying, what is the limit here? This is same as saying, what is the limit? So what is the limit as x tends to 0? And of course, it actually tends to 0 from positive side of the log of x, right? So if you evaluate this limit here, this limit will be minus infinity. Of course, I will show you in a few minutes, so don't worry about this part here, right? Just, I mean, this to note this. So this one here will be minus infinite, right? This one here will be minus infinite. So now remember, we already have the two integrals here. So we have this one. Sorry, we have the lower limit, and then we have the upper limit, right? And then we know that, okay, now we know what will be the value of the integral. So the value of the integral, we have to take this value here, right? So we have to take this part here, right? And then multiply with the CDF and UK, and then the LK, which in this case here is L1 and U1 So just take this part here and then multiply by this part here. So that is actually what we have to do, right? So next, what we are going to do now here, right, is actually saying, okay, that thing, now the expected value of the first integral, sorry, of the first integral. So the value of the first integral, which was from 0 up to m, right? Maybe let me use 20,000. The integral from 20,000 of f of x dx is simply equal to e, and then of course we have to take the mu plus 1 over 2, and then sigma square, I think, and then we have to multiply with the phi of the upper limit, right? So the upper limit, if you remember, it was this one here, 1.2332, and then minus the phi of minus infinite, right? So this is where now I told you it's very important to remember this part here, because we know this part here should be equal to 0. The probability of x being less than that, the area under the curve will be equal to 0, right? So what you're going to end up getting if you evaluate this integral here, so maybe remember this one here will actually go, so this one is 0, right? So if you evaluate this, of course, you'll need, the table for for this part here. But if you do that, I think you will get, and remember this part here, you don't have to evaluate it because you know the answer, right? This is actually what we got at the beginning. This is actually 6, 7, 6, 8. So we have this value already, right? This one here. So we have it already. So we simply need to look at the table. What is the value of this one here? And then if you do that, of course, we'll be able to get, I think, around, where did I put this? So I think we'll get 65. No. Okay, I did not find, like the answer for this integral here, but you can try this one here. So look at the table. I'll give you the final answer, right? So look this one here. So look at the normal table, right? So look at the normal table for this part. Okay. So now this is actually the first integral, if you remember. So it's only this green color here, right? So now we have the other integral as well, but the second integral, is easy. Why? Because so this was the first integral. So the second integral, remember, we want to find integral from m to infinity, and then m f of x, and then of course d of x. But of course, this is actually equal to m to infinity, and then of course f of x, and then d of x, right? But the good thing about this one here, again, you have to evaluate what is a u, k, and then what is l, k, the upper limit and the lower limit, right? But remember, our k in this part here is equal to 0, right? So because our k is equal to 0, then remember our formula. So our formula is actually log of, in this case, it will be log of u minus k. It's supposed to be k, and then of course divided by this one here, and then minus k. Sorry, this is k mu. So k mu, and then divided by k sigma, like this one. But k, is 0. So you'll see that this here, all this part here will go, this part here will, no, not this part. So this part here will just be 0, 0, right? So simply need to find the log of u, right? So log of u. So remember, it will simply be log of infinity, and then divided by the sigma. Of course, this one here will approach, will approach to infinity. And then of course here for the lower, remember lower limit is actually m. So you simply need to take what is the log of u. What is our u is 25. This one here, and then divided by sigma, right? But the good thing that everything now is 0, right? So the other part, like minus k mu, k is 0, so it will disappear. So we simply need to evaluate these two parts here, right? And then after that, of course, you have to find now the integral. So the integral from m to infinity of x of f of x, d of x will simply be equal to. Now remember, even this part here, the out, right, which is actually e power mu plus 1 over 2, and then sigma square. Even this part here will be equal to 1, right? So you don't have to worry about it. So you have to focus on this part here, which is phi of the upper limit. So the upper limit, remember, is infinite, and then you subtract, and then of course you have phi of the lower limit, which I think if you evaluate that will get around 2.033 3, something like that, 0.333, like that here, right? And then after that, of course, you know the phi of infinite. The phi of infinity is 1. So remember, I showed you before that this, oh, sorry. So what I'm saying here, we had this phi of infinite, but we know the phi of infinite, this part here, right? The phi of infinity is simply equal to 1. So it will be 1 minus what you will get in the table. But this one here, again, it will be equal to 1, right? Why? Because we know that, oh, this is K mu, right? It's supposed to be K mu. And then this is K sigma. So K mu, K sigma, if we substitute 0, everything will go, right? So at the end of the day, if you combine the two integrals, you should be able to get the final answer, which is 6,557. This one should be the final answer. It's not hard because what we have been doing so far here is just, math, right? How can we integrate? How can we evaluate these two integrals, this one here and this one here? And you simply need to use that formula or shortcut which I showed you before. So I hope we'll go through this one here. It's not hard. That is what I know because it's just a math now. How can you simplify this integral, right? So any question maybe if something is not clear? Any question? Does that make sense? Au nimewachanganya zaidi? So does that make sense? Yes. No. Okay, Glories. Okay, thank you. Belisima, Glory, kwa nini K is equal to, okay. So K is equal to 0 because in the formula which we actually, this is actually the shortcut we are using, right? This is actually the shortcut we are using. And we are saying if you have an integral of this nature, right? Meaning that you can have any integral. It can be x power 3, x power 4, x power 5, x power 1, x power 0, which is 1, right? So the integral I was trying to estimate was what is the integral from m to infinite of f of x. I did not have anything here. Si ndio? Nilikuwa sina kitu chochote hapo nyuma. Si ndio? It was simply m to infinite and then f of x. So what I'm saying, this part here, I'm saying if you don't have anything here, it means that you are trying to evaluate the integral from m to infinity of x power 0 and then f of x d of x. But what is, right? Yeah, because we know x power 0 is 1, right? So my k order in this part here is equal to 0, right? Why? Kwa sababu sikuwa na kitu chochote hapa nyuma, si ndio? Nilikuwa niko na f of x peke yake. So that is why I said the order of this second integral here, if you remember, this integral here should be 0. My k should be 0 because I don't have anything in this part. Okay, no worries. So any other question? So this kind of question is easy. Trust me, it's easy. You simply need to substitute all the things which you have, and then you have to solve that. And I think I have like a good exercise for you to do here. I don't know. Probably Nishai kuuliza this one here at some point. This question. I think Nishai kuuliza at some point. But what I'm saying. Oh, where is my screen? Can you see my screen? Okay, can you see my screen? Sorry, I don't know what happened here. I cannot see. Okay. Can you see my
cannot
screen?
see the screen. No.
Okay, okay. Okay, thank you. What happened? What happened? What happened? Sorry, 1 second. Okay, so I hope that should be fine now. Okay, so I was saying that I have a good exercise for you here, so you can try maybe to find the way in which you can simplify, I mean, this integral, right? Yeah, sounds like this one here. I don't think I think nishai kuuliza this thing kwenye mtihani mmoja hivi probably zamani. So you can try that. I don't remember, but I think yeah, sounds like that. Anyway, so the what about the remaining amount? Okay, okay. From the first part why you use 0.7 instead of 0.27. Okay, so the remaining amount, we don't need to care about the remaining amount, right? Because that is actually the nature of the question. The question is said, find the mean of the net claim amount paid by the insurer. So we care much about the insurer in this question, right? So we don't have to worry much about how much will be covered by the insurer, right? But if you are given a question about the insurer or maybe both, then of course you'll have to estimate the remaining amount, right? But the remaining amount will be by the insurer, but it's not part of the question for us to estimate how much will be paid by the insurer net of net of their insurance, right? So this is actually not we just have to focus on this one here. Sijui kama ndo swali uliuliza Devota, but that is what I from the first Devota, that is was that your question? Kwamba why are we not estimating the amount for the remaining amount? Yes, Devota. Because it was just the question. The question ilikuwa inataka amount ambayo inakuwa paid by the insurer. Kwa the remaining amount itakuwa covered by the insurer, but that's not part of the question. Yes.
Sema kama the amount get the insurer pay the full amount. Some of the amount. So the insurer paid.
Sijua kama mmesikia swali kwa sababu ana break. Sijasikia vizuri swali kwa sababu ulikuwa una break, yani unakatika. Kwa I'm not sure ulikuwa unasemaje. Basi nikesi kama yeah.
Last time ulisema kwamba verification haijafikiwa, insurer anabidi according to the question the amount haijafika the verification level. Kwa I expected ukicalculate hapo the amount ije sawa na original claim. Naona haija sawa na original claim, kwa reinsurance atakuwa included.
Yani sasa nimekusikia kidogo yani. Sijui ni kwangu tu au ni kwa wengine pia. Swali moja nani Devota. I don't know kwa wengine mnamsikia vizuri Devota au is just up to ni upande wangu peke yangu. Can you hear what Devota said? Hapana. Devota inaonekana kuna shida kwenye your mic, kwa yani una shake. Nitakupa opportunity uulize swali maybe baadaye kidogo, lakini check your mic, inaweza kawa pia labda internet iko stable. Yeah, but I will give you opportunity to ask maybe that again. So let me go through other questions from the first part, why we used 0.75 instead of 0.25. I think it's just the way this kind of contract I don't know, and the way we express this kind of insurance treat, right? So ukiambiwa kwamba is 25% quota share, what it means that this is actually the part of the reinsurer. 25% is the amount which need to be paid by the insurer. If you remember, nili explain I think at some point wiki iliyopita, nitoa example hapa nikasema kwamba we can have this kind of policies, and I said a 25, right, a 25 quota share, what is actually mean is that the reinsurer cover the 25 part, right? Maybe it's just the way we express this this kind of contract. Ndio, kwa kuchukua hii contract itaandikwa kwamba okay, 25% quota share, but what it means that 25 with the amount will be paid by the reinsurer, not the insurer. Market the insurer inatakiwa uchukue 1 minus 25. Why are they writing that in terms of I don't know, right? But you can read that. Just pay attention into that, right? But is a good question, right? 25% when I refer to the reinsurer, not to the insurer. But we can find a good reason why they are typically caught the what the amount which the reinsurer has to cover, not the insurer. I hope that is clear. Kama not, let me know. Sungura, kwa nini umeweka K kwenye formula ya U na I pale kwenye mean alafu amna kwenye formula? Kwa nini umeweka K kwenye formula ya U? Okay, formula ya U. Now that's what is na K. They both have I think it does not matter, right? Because either nilisahau au ni fine. It does not matter. So what you are doing ni kwamba tu I'm expressing, okay. Anyway, yeah. Maybe to avoid confusion, so we are integrating this. So this refers to the original values. No maana hazina K. Sorry for that. This refers to the original values. No maana hazina K. Manake K is the transformed one, the transformed limit. Yeah, I think good. A good observation, Sungura. The reason why there are no K in this part here, because these are the original values. Now this one here, the transformed values. So also we need now to use them in the new formula. So sorry, I think it was just a mistake. Nilikuwa this one here bila pay attention, but we don't need this UK because this is actually yeah, nadhani kwingine nilikuwa sijaweka, but you don't need that because that should be we are making reference to the original, right? These are the original limit, the original limit. So you don't need to put K in that part. It was an error, I think. Yeah, thank you, Sungura, for noting that. And then why in log mean and mean is Loveness, I think it was a mistake. Sometimes nakuwa niko haraka sana, but sorry, we know the mean, right? So the mu is actually 0.85, right? Kama niweka 0.0 kama niweka oh, sorry, what is the mean? Kwa niangalie tena, sorry. The mean is 8.5. Kwa kama kuna sehemu niweka 0.85, it is just a mistake. Nilikuwa nimekosea tu. But I mean, yeah, it's 8.5 like this. Kwa kama niliweka somewhere, I don't know ni wapi, kama nimeweka 0, Ndawiga nakuwa niko haraka sana, kwa hiyo I don't pay attention to this thing, but msifanye this mistake. Just understand the idea behind this. Hizi mistake ndogo hizi nakuwa niko haraka sometime kwa nakuwa nafanya hizo mistake, right? But ni 8.5 mu is 8.5, so just use 8.5 everywhere. 8.5, yeah, but thank you for noting that. Yeah, nadhani maswali yameisha. Mimi hapa sisikii. Ismail, mimi sijaelewa from the first part why we use 0.5 instead of Ismail. Sijakujibu bado. Ismail bado sijajibu au nishajibu? Ismail. Okay, so if that is okay now, I will actually move to the second part. And in this second part, because this is actually the previous lecture, so now move to the second part. So the second part is again is just the continuation of this lecture here. But now we are saying of course, the quote of today here, when I summarize quote of today, I can ask you that what do you understand by this quote of today anyway? So inflation does not just inflate claims, it expands the responsibility of the insurer and insurer alike. Kwa sababu inflation or you're expecting inflation, then you'll have to adjust for that, sindio? Kwa sababu you are making that arrangement today, right? But this arrangement probably will run maybe for 1 year or maybe 2 years. We don't know the term of the contract. But so if the contract is going to run, let's say for 2 years or 3 years, then we have to make sure that we take into account inflation, right? Because inflation is always there, right? The only issue is like maybe inflation is going to go up by how much, and I think that is very important. So we are saying this part here. Suppose now we have to take into account some kind of inflation and stuff like that. Because remember, in the previous questions, we just said if your claims amount exceed, let's say 25,000, of course that is a good news. You just pass everything to the reinsurer. But we are assuming M to be constant. And the question is, does the constant assumption in this case here make sense or does not make any sense? And probably, I mean, I don't know, but I think it does not make any sense to assume the constant retention level. So let us, cover this. So how can we deal with claims of infractions, and then we have policy excess and deductibles, and then we can see how we can estimate the parameters. So it's a very simple extension of what we actually started. But we are saying in this part here that maybe the main motivating questions is like, okay, suppose that claims amount increased by a factor of K, right? So all claims amount increase by a factor of K next year, right? So while the same excess level is maintained. So suppose we say, okay, claims goes up, but let's say there is no any changes in the contract. So if you entered, let's say, contract this year, we expect the same, let's say, to continue to be next year. But we know next year, like the claims amount are likely to go up, right? Let's say because of inflation, and we are assuming, it will go up by a factor of K. So we are saying, well, the same excess level is maintained in the excess loss treaty between the insurer and insurer. Should we expect the insurance average payment to increase by exactly K? If not, would it increase by a factor which is more than K or what, right? So if we maintain the same retention level, and let's say claims amount go up by a factor of K, which denote inflation, what should we expect in the average amount which the insurer has to pay at the end of the day? Is the amount which the insurance company going to pay also going to increase by K, or is going to increase by a factor of less than K, right? We don't know these answers. Based on this, how would the reinsurer average payment change and stuff like that? So these are the motivating questions actually in this simple extension. That if you have inflation, what should we expect in everything which we have been doing? Should we expect the mean to go up? Should we expect the mean to remain the same? Should we expect the mean to actually, something like that. So what we are saying is that we are saying this one is not a straightforward answer, probably. It's not a straightforward question. And the reason why it's not a straightforward question is because you can have two cases. You can have a case where you have, let's say, small claims, or you can have cases when currently you have, let's say, larger claims. Because we're just saying, okay, what will happen to your claims payment if, a claims payment, let's say this year, goes up by a factor of K, right? But so we are saying, it depends. If, we have small claims this year, right? If we have small claims, and more specifically, assume maybe we have these claims here is less than M divided by K, right? Where M is actually the retention level. We are saying, of course, we expect next year, right? Because of inflation, then our claims will be KX, right? Will be KX. But KX, based on the assumption, will be less than M, right? So of course, if we have small claims, then of course, our what we have to pay will actually go up, right? Like that. Why? Because it's like this. So you are saying, maybe like not too official example, but you are saying, if I have, because I know I'm an insurance company, let's say I'm starting here, and then here is the excess, and then I'm saying everything beyond this part here is for the reinsurer, right? This is for the reinsurer. for the reinsurer, right? So we are saying if my claim this year are small, right? If my claim this year, let's say at around this level here, of course, if I mean inflation increases these claims, right? Of course, they will still be within this region here, right? Because they will go up. Maybe you'll have to pay this amount here because of inflation, maybe up to that level, right? Because of inflation, which is actually much actually K. So the second scenario we are saying, but if we have larger claims, let's say claims maybe this year are in this level here, right? And then of course you maintain the same excess level, right? If there is an increase by a factor of K, of course that is a good news to you, right? It's a good news to you. Why? Because everything will be passed now to the reinsurer, right? Yeah, because so we are making an assumption that if I mean KX is greater than M now, everything will go to the reinsurer. So we don't expect the claims of insurance company to increase by a factor of K. Why? Because you know that the amount, all amounts which are higher than M, if will not be your responsibility, right? Anyway, you will see this one here. But the simple assumption is like, if you have smaller amount, let's say you are at this level here, then inflation will actually drag this up, right? So this will go up, right? But we are showing if it goes up, not beyond M, I mean, it's still your problem, right? So you'll have to handle this. So your claims will go up by a factor of K. But if you have larger claims and then you multiply by K, that K will take them out. So they will go to the reinsurer, right? So this is what we are trying to argue in this part here. So we can have small claims, right? Or we can have larger claims. If we have small claims, then we expect the amount which you have to pay as the insurance company should actually go up by a factor of K. But if we have larger claims, let's say this year, and then we expect maybe K inflation next year, we say that is a good news because larger claims, if they exceed M, then everything will go to the reinsurer, right? So I don't know if it makes sense, but if not, I'm happy to take any question. So again, everything now remains the same, right? Just like what we did before. But remember, we are making a very crude assumption here. Very crude assumption that inflations, right? Inflation drag the amount which we have to pay up, right? But the retention level remain the same. So it's remain M, right? That's why we are saying the amount which is going to be paid by the insurance company, let us denote it by Y star, not Y, to differentiate between inflation adjusted claims and original claims. So we are saying if inflation, let's say, if inflation adjusted, okay, so the inflation adjusted claims will be equal to, so the insurance company will pay KX if KX is less than M, right? And then it will pay M if KX is greater than M. So what do we have to prove in this part here is that then the amount paid by the insurer next year on a typical claim X is actually this one here. So we have to prove this one here. And I think I asked this question at some point. Nadhani wanafunzi walikuwa wanachukulia this concept here very I was explaining this one here and I think nobody cares. So I decided to ask this one in a test here, I think na sikumbuki walipata watu wangapi hili swali. Very simple question, but I think very few got this question right. So sorry. This question right. This question right. Yeah. But is a very simple proof. But I want you to explain. Nenda mkasome afu explain why this makes sense anyway. But that is the main idea here, right? So I will prove this one mathematically, but let me go here, right? So everything is the same. We want to find what is the we want to find what is the mean of Y star, right? In this part. But we know the mean of the Y star is simply the integral from, so we have 0 up to M, not M, because I'm integrating this one here with respect to X. So if I'm integrating this one with respect to X, I don't need KX here, right? So I'm going to write this one here as X less than M over K. And this one here is, of course, X greater than M over K, right? I mean, I hope it makes sense because I have to take the integral with respect to X. So I'm saying now this will be the integral from up to k, and then x, and then kx, and then f of x, and then d of x, and then plus the integral from m of k up to infinity, right? And then this is m, and then of course we have f of x, and then we have d of x. So it's just like before, except here now we have k, right, which is actually the inflation factor. So what I'm saying in this part here, that because we are proving, so we have to arrive at this point here, right? That is the reason. So you see, I mean, I'm trying to manipulate this one here, but the main reason is that I just want to arrive here. So now we are saying in this part, we can find m, because we know that for us to be able to define this one here, we need m in the limit. If you remember, we need to have m. So I will do this thing because I know my limit is just defined like this one here. So you have, let's say this is 0, and then you have, this is m of k, and then maybe you have your m is here, right? So what I'm saying that instead of me writing, let's say this part here, right? Instead of me writing this part here, I can take the integral, maybe, or maybe we can factor out maybe k first so that it makes more sense. So this is the same as writing. So I'm going to take out k out, and then the integral from 0 up to m of k, and then this will be x, and then f of x, and then of course dx, and then it plus. So this one here will be the integral from m to k to infinity, m divided by k, and then f of x, and then of course we have d of x, right? Just factor out k, and then what I'm going to do, that I'm going to say the integral from mk to infinity, right? Because let's say infinity is here. So instead of me taking the integral from m to infinity, what I can say, I can take maybe the integral from mk to m, and then I can sum with the integral from m to infinity, right? Just the same thing, but I'm doing this one here in partition. So I'm going to have this one is k, right? So we can take now the integral from 0 up to mk, and then x d of x, and then it plus. So instead of having this integral here, because I'm just going to change this integral here now. So this integral here will be in two parts. So I'm going to have the first part is mk up to m, and then of course m divided by k, f of x, d of x, and then plus integral from m to infinity, and then this one is actually m of k, f of x, d of x, right? Like this. So now this is actually the same integral, right? Just the same plain integral, right? What I've done here is simply to try, to combine the two integral which we had. Based on the interval, right? Because mk to infinity is same as taking mk, take a break to m, and then continue from m to infinity. So what we know from here now is that what we can do is that we know, because we want to prove this thing, right? We want to prove this thing. So what can we do, right? We know one thing here that, okay, this is actually somehow tricky now. So I'm going to say, okay, I'll do some manipulation here, right? So I'm going to change this part. So let me leave this part here as it is. So I'm going to say, this is the integral from 0. So we have our k here. This is the integral m to k, and then x, f of x, and then d of x, and then plus, this is m of k, and then actually m. So I'm going to replace this one here, right? mk, I'm going to change it to x. Instead of mk, I'm going to replace this one here, and then I'm going to write x, and then f of x, and then d of x, right? But what I know that in this interval from mk to m, sorry. So this is mk over m. But what I know in this part here is that in this integral from mk to m, I know x is greater than m over k, right? So if you replace, instead of writing m over k, if you write x, it means that the value of this integral here will be larger compared to the previous integral, right? mk and x. I know x is greater than mk in that interval which we're trying to integrate from mk to m. So if you find this integral, if you evaluate this integral will be larger, right, than the previous one. And then I'm also going to change the next integral, right? So here I'm going to say the integral from m still to this one here, but I'm going to change mk, right? I'm going to replace mk with m, right? F of x, d of x, right? So now we can see this green part here. This is the modified part, right? This is actually the modified part, this part here. This is modified, right? So modified. So this is just the modified part. And what I'm going to say in this part here now is that I know this integral here will be larger than this, and this integral here will be larger than this one here, right? Okay, so Ismail, what I'm doing here is that I just want to arrive at this point here. This is actually my target, right? So the question is, how should we do that? And we are saying, okay, I will explain what is the motivation why I'm doing this one here, but the general idea is that I'm saying, okay, let me replace mk with x, right? But if you do that, you know that this new integral is x will be larger. The value will be larger compared to the previous one, right? Maybe larger or equal, we don't know, but it will be larger in general. Why? Because I know x is greater than m over k in this interval because we have mk up to m, right? So we know x should be greater or equal to m over k in that interval. And in this part here, we are saying if I'm going to replace m over k, right, with m, I know this new integral here will be larger, right? Why? Because I know m is larger than this part here. So instead of me writing equal in this part here, I'm going to write here. I'm going to write like this one. Here, I'm going to say this new integral here will be either larger or equal to the previous one, right? Because just like assume maybe you are writing these integrals here. So you start with this and then, so this will be less. This integral here will be less than this one here, than the new one, because of the manipulation which you have done, right? And now we are saying, now it's very easy because what we can do, we can say k now is actually the integral. So we can combine 0 to m. So we can have the integral now from 0 up to m over k. So up to m, because it's the same integral now. This one here and this one here is the same integral. So we can take 0 up to m, and then x, and then f of x, and then d of x, and then plus the last integral, which is infinite, and then m of x, and then d of x, and then this one here. So I believe this one now sounds familiar, right? This should sound familiar. Why? Because we know that this part here is simply the expected value of y from the other lecture, right? So that is why we are saying that in general, if you estimate the mean of the adjusted claims amount, and then you are assuming the same detention level, then of course this mean should be less or equal to k, and then expected value of y, this one here. So now this is what we needed. So this is actually proved. So we wanted to prove this thing, right? And I'm saying if we replace mk with x and then m with and then of course m over k with m, of course we know that new integral will be larger than the previous one. So I expect you to understand why this thing makes sense, because I think I asked this question. Yeah, I will show you. I think it was last year test, and I think what will fail is under this question. Because I mean it does not matter, because one of the reasons why I think last year students were not happy with with the exams is because I think I want you to understand the ideas. I know you're good in math, right? I know you can do the integrals, you can do the calculus, all these complicated stuffs. But I want you to understand the what is the idea behind this thing. So why are we doing this? Because that is the issue. Sindio? Nitoa mtihani ulikuwa sijui wanasema maswali mengi yalikuwa ni ya ku-explain, and course inaonekana ni ya kusolve na nini. That is not an excuse, right? So you should be able, at least, to understand why are we doing this thing, because at the end of the day, you'll have software and everything will be doing everything this for you kama ukienda in practice, ndio? So in practice, we don't have integrals, we don't need this, right? We need, this idea so that we can develop more probably, but how many end up developing more, right? I mean, probably few, right? Or maybe none. So at least we should be able to understand the well, why are we doing this and why probably this thing makes sense or not. So the other thing is actually, I will leave this one to you to think about is why do you think this thing makes sense, right? Of course, you have the answer already kama umeshafuatilia pale mwanzo. So unless if you have any question, maybe at that point, which I'm happy to take. Question maybe. And if no, of course, I will actually move on. Of course, vitu vingine huku ni just, I mean, okay, so I think you have some, yeah, so I'll leave that to you, I mean, to read and understand. And I just want to focus on the other simplifications. Of course, kuna baadhi ya books you can read, they're trying to actually simplify all this kind of equations, to make, I mean, the computation much easier. Na a good example, for instance, ni kama hiyo hapo. We have the following derivation give the useful expression of expected value of y star. Of course, we can write like that one. Sio tu kwenye case ya inflation. Hata case ambayo hauna inflation, you can have, I mean, simplification like that one. Yeah, hakuna kitu chote ambacho ni special here kwa sababu what they've done, they've said, I mean, I'm talking about this part here. About this part here kabla kwenda kwenye that second thing. What we are saying this part here, we are saying the expected value of y star in that part is simply equal to okay, so we remember that here hapo huwa inakuwa ni integral from 0 kama tulivyofanya mwanzo, m of k and then kx and then f of x and then dx and then plus the integral from m over k, and then of course to infinity, and then of course we have m, and then f of x, and then of course we have d of x, right? So what we can do here, so we can see here tuna k iko nje, si ndio? We can factor out k. So we can say, let us take out k, and then we're going to remain with the integral, and then m to k, and then we have x, and then we have f of x, and then of course we have d of x, and then of course we have plus integral again, m over k, and then m over k, and then f of x, and then d of x, right? And then we can say, because we can see about to prove the expected value of x. It means that we can make this one much easier if we again if we consider the interval. So we can get the interval. You have 0, you have m over k, and then you have, let's say, m, and then you have infinity, right? So to the expected value of x upper, this, remember, is the integral from 0 to infinity, right? So we should probably expect that that first integral by taking, let's say, let us take the integral from 0 up to infinity, and then we can subtract the remaining part. Because the remaining part now here, itakuwa ni part from mk to infinity, right? So I'm going to take 0 to infinity. I'm going to subtract mk to infinity, which will give me the same thing. So just like what we did before, so this will be equal to k, and then integral from 0 to infinity, x, f of x, d of x, minus integral from m over k, and then to m of k to infinity, and then we have x, f of x, and then d of x, and then plus the remaining integrals. Integral will expand in here by just expand this. So this is actually the same thing. This is actually the same integral now, right? So I'm going to plus with the remaining part in this part, which is m over k, and then to infinity, and then mk fx, and then d of x, and then this one here. So now if you do this, of course, you'll be able to see that this will be equal to, so we can combine this, because now we can say this is k, and then integral 0 to infinity, x, f of x, and then dx, and then subtract. So in this part here, you're going to have, so we're going to have x integral mk to infinity, and then x minus mk, and then f of x, and then d of x, like this. So this will be equal to k out, and then we know this part here, right? We know this integral here, right? This integral is simply the expected value of x. The expected value of x, subtract m of k to infinity, and then x minus mk f of x, and then d of x, right? So we can simplify this one. We can let maybe y is equal to x minus m over k, right? So if we do that, we know this will end up being equal to k, and then expected value of x minus so the integral now, because now we are changing. So we have to deal with y. So instead of having mk, so I'm going to have the integral starting from 0 up to infinity now, right? So if we substitute m over k, we're going to get 0, the lower limit. The upper one will remain infinite. So we're going to have this part here will be y. So y, and then f of x. Remember, x will be y, so it will be f of y plus m over k, and then d of y, because in this part here, d of y is equal to d of x. Because this is actually what we wanted to show. Nothing special here, I think. It's just, showing you kwamba kuna other ways in which you can express the mean. So this is the mean of the adjusted claims amount. So this is just calculus, I think. You can take a look maybe later. I don't think kama kuna kitu ambacho ni complicated. And then we are saying, in case kama hiyo x yako ni exponential distribution, if your x is exponentially distributed with parameter mu, then of course the mean will simply be equal to this one here. So you can try now, baada ya kufanya hicho kitu, you can try now to find what is the mean of that thing. Kwa sababu kama una exponential distribution, is very easy. You know what is this one here? This is 1 over lambda. The mean of x is 1 over lambda. So you have to simply take the integral of y, and then of course remember you have lambda, and then e minus lambda, and then so lambda, and then y plus m over k, and then lambda. So just take the integral when you have an exponential distribution. Now simplify, of course, you'll end up getting this this part here. Okay. Yeah, so huku ni math, just math. Hapa kuna swali ambao ni very simple again, kwamba a typical claim is modeled by an exponential distribution with the mean of 100 and excess of lossly insurance treaty is in effect with excess level of m is equal to 150. So you have, the mean of an exponential distribution. So this is actually 1 over lambda, and then of course you have the m already. So find the expected cost per claim for the insurer under this arrangement. Ndio kwa excess of loss. So what I have said ni kwamba kwenye excess of loss pia you can have some simplification. Kwa kutumia the same approach ambayo nimeonyesha mwanzo, you can assume this approach here ambayo nimeambia kwamba you start from here, right? So you start from the mean. So the mean is actually given by this one here. Now, if you have an exponential distribution, you just have to substitute the mean of x in this part is actually 1 over lambda. And then what is actually this second integral here, right? Of course, you just have to integrate this second part here, and then you have to simplify it to come up at this point. So remember, we are doing this one here for y star, but you can do it for y as well. So y, we don't have this m of k, we just have m. So you can develop the same formula if you have y, so your y star. So you can develop that. And here I'm saying that if you have, let's say, if you have if you have a y, not y star, of course, the mean will simply be by this one here. You need the same approach. Now, remember, come exercise here, you can try to prove. Now, because everything you have all the data. Remember, you have m, because you have to find what is expected value of y, right? But you can see we have everything. So we have the lambda, we have the m, simply substitute, and then you are done in this part. Now, sometimes we have to develop this simple formula so that you can easily, estimate the values like this one here. So la pili pia ndo ile ambayo nimetumia that formula kwamba suppose now the inflation is 6%, right, is expected for next year, and the excess level remain the same. In the assumption about tumekuwa tunafanya all the time, we are making an assumption that the excess level remain the same despite the fact that inflation has gone up by 6%, right? So what you have to do ni kwamba now unatumia this formula here ambayo I have given you here, kwamba in case you have x is your exponential distribution, then the mean is actually this part here. Expected value is equal to k lambda 1 minus sikuwa mnaikumbuka hii formula. Yeah, kwa sikuiandika, nilikuwa nimesahau, but what we have now is very simple kwa sababu we know the mean of the y star is simply equal to mnaikumbuka hiyo formula? Kichwa changu siku hizi akitunzi vitu. um, where is it? Just want to copy it here so that you can follow. Maybe that is lecture number 3. Yeah, so that you can maybe follow that parameters, and then okay. Okay, so 1 second. Okay, so we are saying that if you have x, y star and you have an exponential distribution, the formula is simply k divided by lambda, and then we have 1 minus e minus k over m, and then multiply by lambda. So now you can see you have all the thing you need, right? M is equal to 150, and then you have your lambda. Your lambda is equal to 0.01, I think. You'll check easier than nikamake, or you'll check kama ni sawa. And then your k is 6%, si ndio? Kwa maanake my k is just actually 1 plus 0.06, like that, si ndio? Or my k is equal to 1.06. Sio katumia 0.06, I mean utakosa. Ni kama you are saying this was my original claims, and then my claims increased by 6%. So the multiplying factor in that case should be 1.06, not 0.06. So that will be the increment. So what is the total claim which you have to pay under that contract? So your k is this one here. So you have everything. You have your k, you have your lambda, and then of course you have the retention level. So you can simply substitute everything, and then you are done. Kwa zingine tu ni I think you can actually read that. Yeah, so we'll be done in a few minutes, but I'll give you like maybe 2 minutes break, and then after that I will actually continue. I just want to move from iPad to desktop. I don't think if I'm going to write again. So yeah, you can take this just like a break, 2 minutes. So let me switch this. And you guys don't pay attention kwa sababu I say let us take 2 minutes naona kuna watu wanasema kwamba hawanisikii. Mungu mna shida gani you guys? I said let us take 2 minutes and then we'll come back. Lakini naona watu mnalalamika in the chat kwamba mnisikii. Yeah, that is very surprising. Kwa siona kama mko yani mnasikiliza this class. Um, anyway, yeah, so I'll just comment one thing kwa sababu kama nakumbuka kwenye ile swali la kwanza, we said the log of infinity ni the log of infinity ni the log of infinity ni sorry, the log of zero tuweka minus infinity, si ndio? Kwa na just want to show you kwa sababu nilikuwa sijarudi kwenye desktop. Kwa maybe I can show you here quickly. Yeah, so 1 second. So I can show you that this is like, so it's like taking a limit. Because if you want, let's say, estimate COD the log, send your y maybe is equal to log of x. Log of x. And you can see this one here. This is the graph of the log. The graph of the log. So you can see the graph of the log. Now this is just I mean the typical number line. Now you have this. If you are approaching zero from the this graph is this is approaching zero from the positive side. Sindio? The more you approach zero, sindio, you take the log of zero or limit of log of x as x tend to zero, can see that you get negative infinity. Sindio? Negative infinity. Maybe let me do this one here. You can see the way of course nani shape inapotea, lakini you can see kwamba hii ndio graph inapokaa kwamba the more you approach zero, you can see the limit is going to minus infinite. So maana we say the log of zero, right? Of course we are approaching zero from the positive side based on this figure here. So it should be equal to minus infinite, so positive infinite. Kwa ukika positive infinity, I mean you are now you are doing your own estimates. Yeah. And the other thing which I wanted to comment, I wanted to show you, I don't know, yeah, what I wanted to comment again. Anyway, I don't remember, but if I remember, I will actually comment that again. So let me now finalize this one here. So we have covered this one here already, and then showed you that this simply just need to substitute in the formula like that. But again, so you have seen that the assumption we are making in that case, I mean, it does not make any sense. And the reason why it does not make any sense is because we are assuming the retention level actually remain the same, right? Which is not, I mean, it does not make any sense in the real world, right? So most of the time we'll find that all these retention levels are linked to inflation. So as the inflation goes up, of course, you expect the retention level to go up as well. And if the retention level goes up, right, as the inflation goes up, you expect, all the payment for the reinsurer and the payment for insurance company to also increase at the same factor, right? Because everything changes at the same factor, right? So if, inflation, let's say is 5%, you expect, the same impact to be reflected in the retention level as well. So that is actually the key thing which I wanted to comment in this slide here, right? So it does not make sense to have the constant retention level. So retention level will typically be linked to inflation. And of course, in developed countries, they also have this, there are specific indices published for the use with general insurance claims to help guide how retention level adjusts over time. So this is should be linked to inflation. Should be a function of it should be a function of inflation and not a constant number like what we assumed before. But probably now, if you adjust inflation, now, of course, the estimation becomes somehow challenging, right? And that is why probably in the textbook, just for learning, we just assume that everything is constant, right? Because it's easy to do. But if you try to adjust for inflation, I think everything now changes and it becomes somehow complicated. So, of course, I just want to comment again on deductibles. So I believe you are familiar with deductibles. And I believe some of you probably you have insurance, maybe for your cars, I don't know. But if you have your insurance for a car, of course, you'll have a deductible. So a deductible, if this is familiar to you, is like, it's just like when you have insurance company and the reinsurance company, right? So insurance company say, I think I cannot, I will not be able to cover all the claims. And because of that, I'm going to take the reinsurance cover, right? So deductible is the same way, but now who is involved in this part here is actually the policyholder and the insurance company. So ignore the reinsurance now. you are talking about the policyholder and the insurance company, right? And the insurance company, remember, sometimes we call it a seeding company. So ukisikia nimesema seeding company, ni the same as the insurer, ni the same as the writer, I mean, many names. So if you are the policyholder, in your contract you'll have deductibles. Deductibles ni amount ambayo kama ukipata loss, wewe kama policyholder, you are supposed to cover that part. Kwa mfano kama umechukua insurance labda ni ya let's say ni ya pikipiki kwa mfano, atakwambia kwamba ukipata loss labda ya shilingi 5,000, that is up to you. You should not come to the insurance company claiming 5,000, right? So you'll have deductibles, but many people, they don't read, I mean, the terms and the terms and conditions of the insurance contract. Kwa unashangaa mtu akipata loss hata tu hela ndogo atakaenda kaida insurance company. It does not work like that, right? So you'll have deductibles. So deductibles, I mean, yeah. So of course, this is just, I mean, fixed amount. Ni kama tu position ya insurer na reinsurer, but now just forget about the insurer. Let us talk about the policyholder. Kama policyholder, you have to cover your part. We will cover your part as well, although you are giving us premium. There is a reason why there are deductibles, right? Na hizi deductibles inawezekana zikawa ni fixed amount, labda wanakuambia kwamba ni 5,000 deductible. So if you are claim from any loss, let's say it's 5,000, of course you should not come to us, right? Or it's below that. You should not come to us. Please cover that yourself, right? But you can also have proportional deductible, just like the way we have proportional insurance and stuff like that. So here just, I mean, some examples of these, some types of these deductibles, right? So in some health insurance policies, for instance, in US, they typically introduce 20%, I mean, deductibles. I don't know, but definitely health insurance contracts, but probably, I mean, you are familiar with this one here. Sindio, like no shanga maybe ni in terms of proportions. Kama in terms kama, let's say ukiugua, sindio, kama your total claim, let's say ni 100,000. Of course, 20% of that you should be able to, I mean, to pay yourself, and then you are going to pay the remaining one, which is 80%. So, I mean, this will be stated, right? It will be stated in your contract, but you can have either a fixed amount or you can have or maybe you can have a proportion. So maybe what is interesting, this one here is another type is franchise. Franchise or minimum deductibles, where insured receive the full compensation only if the claim amount exceeds the threshold D. So this is actually what is actually typical, and you can link this one to excess of loss. And excess of loss in this part is that you, of course, will be covered only if, I mean, your excess exceed the D. So the D is like the M, right? But this one we call it a deductible. We don't call it the excess of loss like what we had before. But otherwise, I think everything remains the same. So I hope you can lead this concept. I think they're very easy. So there are several reasons why, I mean, insurance company might need to introduce these deductibles, right? And first of all, is just help to reduce the number of small claims submitted to the insurer, which is often not financially significant, right? Ni kama usumbufu muda mwingine, kama ukimruhusu mtu akipata claim yote ile, time imevunjika, sijui nini, gari imeingia sio wapi, yani ni usumbufu. Just reduce these small claims. And the problem is that these small claims, although ni ndogo, insurance company maybe is like a cover at some point, but processing small claims is often administrative expensive. Sindio? Remember pale tunatakiwa process hizo claims, wafanye nini, why have that cost? So that is why insurance company has this limit that unless if you are serious, then you come to us. If you are not, please fine, just cover that yourself and stuff like that. But it probably, I mean, it's just like a marketing strategy. And the reason why it's a marketing strategy is because think about maybe not marketing strategy. I don't know how I should put it, but it makes their product more attractive, right? Why? Because if you don't submit all these small claims, and we said maybe this they have some cost implications. If you are removing all these costs, all these small costs, it means that even the premiums will be somehow low compared to when you allow all the claims to be submitted to the insurance company, right? So you can see at the end of the day, the premium which the insurer, which the policyholder has to pay under the excess, under the deductibles will be somehow low compared to when they would have paid otherwise without having these deductibles. So that is why we are saying they at least, I mean, make some of the products maybe competitive so that insurance company can compete and stuff like that, right? But most people, they don't understand that we have deductibles. Ndio, most people who hawana knowledge ya insurance, kwa wanapoenda kwenye insurance, they assume that ukipata loss yote ile, you can just go to the insurance and insurance company will be able to pay you. By the way, even insurance company who waambia watu sometimes, they hide those stuff, right? And the reason why they hide ni kwamba mtu ambaye hayuko familia na insurance kwanza kumwambia kwamba ukipata loss kuna amount utakava wewe mwenyewe, kuna amount utakavia mimi. Yani, people will not understand that, right? Because I'm giving you my money. If I'm giving you my money, I expect, I mean, in case if I get any kind of loss, I should come to you and then you should be able to actually cover that for me, right? So that is not how it works. So most of the time ni kama kamali tu. People, they don't say, kwa mtu anaenda pale shangaa amepata loss, anaenda pale anamwambia no, let us go to your contract, and you can see in the contract we have this called deductibles, and this deductibles, of course, is the amount which you have to pay yourself, right? So yeah, you will see this kwamba mtenda kufanya kazi kwenye insurance, and of course will be more yeah, so you can see even the structure now remain the same. You can see now the amount which need to be paid by the insurance company, you should actually take into account the deductible. So it's actually X minus D rather than X, which we assumed before. So the mechanics remain the same, just like what we saw before, right? So I just want to end with this just quick note. I will not solve the example because I think it's just the same. Just like what I showed you before about the distribution of the claims to the reinsurer. I said, of course, the reinsurance company is going to have a truncated distribution. And the reason why it's going to have a truncated distribution is because they don't get to see all the claims which insurance company has, right? Why? Because the insurance company will pass only, right, claims which exceed M, and all claims which are below M, I mean, they don't need to know, right? I mean, it's just, I mean, it's not just their business, right? So of course, it's the same thing here. Now, to the case of insurer, now insurer, of course, will also have another problem, right? So let's say a typical claim record might be like this one here. So X1, X2, M, X3, M, and then X4 up to X5. Sindio? Kwa sababu remember, kama this M, which means that here amount ilikuwa ni kubwa in excess of the retention limit. So insurance company will pay M. Because your data will not look like X1, X2, X3, X4, X5. No, you'll have maybe X1, X2, M, and this one is it. So if you're using your data for this data here for modeling, let's say you want to find a good distribution for that, then of course, remember, we're not dealing with the full, we don't have the full picture of the claims amount which we have paid, because some of these claims were paid by someone else, not us. So if you want to estimate, let's say, the parameters of the distribution, we know we can use the maximum likelihood estimate for this case here, but we have to be very careful, right? We have to be very careful because we don't have, I mean, the full picture of the distribution, right? Some of these things are not with us, right? So we are saying in this case, we know we can use the method of moment, we can use the method of percentile, of course, we can use the maximum likelihood estimation. These are the three methods which we covered for estimating the parameters. So we are saying the method of moment here, I mean, is not available, right? Since even the mean claims amount cannot be computed, right? So we cannot have a full distribution of the data, right? So this data, I mean, will be somehow censored, right? And remember, we have to estimate the mean from what we have covered, right? Because if someone else covered, then of course we cannot do that, right? That is not our part. So we are saying in this part that the method of moment is not available in this case here, because the method of moment depends on us having the full, having a good understanding of the full distribution of the data. So if some of the data are censored, I mean, that is usually a problem, right? And of course, we can use maybe the method of percentile. Why? Because the good thing about method of percentile, especially if, I mean, especially if the number of larger claims, let's say there are few, or maybe they are larger enough. Why? Because it is the distribution. So in the method of percentile, you are cutting your distribution, right? Let's say you look at the median, right? If you have one parameter, you have a median, right? So a median is not affected by larger claims. And remember, larger claims will actually pass to someone else. So method of percentile makes sense. Or maybe if it's large enough, we can have full information if up to the upper quartile, right? If you have information up to the upper quartile, of course, you have the upper quartile, you have the lower quartile, you can estimate the parameters if you have two, if you have 2 or 3 parameters in your model, right? So you can see the method of percentile makes sense, right? Because you are cutting the distribution. But when it comes to method of moment, I mean, it actually lies on a full understanding, because if you don't have the full picture about the mean, right? Why? Because I mean, some of the amounts were covered by someone else, then of course, probably, I mean, it's not a good, it will not give you like a good approximations of, I mean, of the distribution of your claims. Yeah, so here we're just, I mean, introducing the same thing, the same concept, same idea, but we are saying now to estimate, I mean, the parameters by using the method of likelihood estimation, what we have to do now, we need to have the two part in this part, not a single part. Now we are going to have this part here, right? So this is the likelihood function, sorry, the likelihood function. So instead of having only this part here, we need to also capture the second part in this part here, right? So this part here capture all claims which exceeded M, right? So you have this part here, which is full X, maybe X1, X2, X3, X4, and all amount which actually goes to someone else. Okay, we paid up to this point, M, and then leave the other to someone else. So your likelihood function should have two parts, the first part and then the second part, which is this one here. So I've added, I mean, some explanation here. So we can have this one here is the recorded claims, which is actually captured by this part here. And then, of course, you have the censored claims, because all claims above M goes to the reinsurer. So this is actually captured by this part here. So now the full one is actually this part. But everything actually remains the same, because you can see an example here, for instance, claims in a portfolio is believed to arise from an exponential distribution. There is retention limit of this one here in 4. So this is your M, because M was the retention limit, and the claims in excess of 1,000 are paid by the reinsurer. So we know in excess of M, everything goes to the reinsurer. The insurer, wishing to estimate the lambda, observed a random sample of 100 claims, and they find that the average amount of 90 claims that do not exceed 1,000 is this one here. So now we